We're going to pick up in lesson 6.4 talking about logarithmic functions like we were yesterday. Okay, we'd already looked at the graphs on the front side, and on the back side we were looking at transformations. We have that same chart provided up there that you're used to seeing all year, and we were looking at, okay, given the transformation, how do the asymptote and x-intercept compare? Do they stay the same? Do they change? And the one we talked about yesterday was log base 2 of x plus 3. We decided the plus 3 takes the graph and moves it left 3. And when you move that whole graph left 3, yeah, the asymptote and the intercept are going to also move. So they're going to change. Okay? Now, let's look at b. b is where we left off. K of x equals the natural log of x plus 4. First of all, what transformation is that? Up 4 units. And why would we say up 4?
Because that's one of the parentheses.
Okay. There are no parentheses, and so since there are no parentheses, we assume it's outside the parentheses. If there were parentheses on this one, they would just be around the x. You don't have to have parentheses there, but if you do, that's where they would be. Okay, so that plus 4 is going to translate the graph up 4. I'm going to write that down first so we have it. Graph translates up 4 units. Okay, now think about this. Let's start with the asymptote. I take my graph from yesterday and I move it up 4. So if I go back here to my previous screen from yesterday, if I take one of these graphs and I move that graph up 4, is my asymptote going to change?
Yes.
What is my asymptote? On these, my asymptote is the y-axis. If I take my graph and I move it up 4, is that going to change? Or up 3, up 4, whatever it was, is that going to change the location of that asymptote?
No.
No. It's just going to take that graph up farther. So in this case, the asymptote's not going to change. Now, before I flip back to my other screen, let's talk x-intercept. If I take this graph and I move it up, is this x-intercept going to change? Yeah, because right now it intersects, both these graphs intersect at 1. If I move this graph up, it's still going to cross the x-axis, but not at 1. And you don't have to give me a specific value. We just have to be able to identify, does it change or does it not change? So, when I come back, and here guys, you need the visual. Okay, if I take this graph and I move it up 4, I'm going to erase that, but that's the gist of what it would look like, right? Asymptote's still the same. My y-intercept's going to change. There's your visual for the day. Okay, so asymptote stays the same or does not change. Okay, asymptote does not change. And the x-intercept, all I'm going to say is it does change. You don't have to give me the new one, thankfully, right? We're just going to say that it does change. Okay, so there's a good example of one where we've got one changing and one not changing. Okay, so in example A, they both change because they both moved left 3. In this one, one's going to move up, the other one, it's a vertical asymptote. It can't really move up. Okay, ready for C? First of all, what is the transformation there?
Vertical stretch.
Yeah. We have that a value out front, just like that. It's just a number multiplied out front. It's bigger than 1, which means it is a vertical stretch by a factor of 5. So I'm going to write that down first, that the graph is vertically stretched by a factor of 5. Okay. Excuse me. Now, what are we thinking about a vertical stretch by a factor of 5? We have to talk about, is that going to change my asymptote? And is that going to change my x-intercept? If we stretch something vertically by 5, what does 5 do? It multiplies your y values, right? Your vertical values by 5. Okay, I keep going back to this page, but it's a good page to look at. So if we take the y values and we multiply them by 5, realize what's going to happen. I'm not saying that's exactly it, but that's the idea of what the stretch is going to do. Okay? With that in mind, if that's what that stretch is going to do, think about it. These y values are going to get bigger, right? So that graph's going to move up. But at the x-intercept, what is it's the ordered pair 1, 0. Is that y value going to change? No. Okay, so x-intercept's not going to change. What about my asymptote? Does it change?
No.
No, asymptote's not going to change either. Okay? So, in a situation of a stretch or a shrink, your asymptote and intercept are not going to change. So, asymptote and intercept do not change. Okay? Okay. One more section?
Excuse me.
Okay, last section. We are back to looking at inverses. We've looked at inverses several times this school year, okay? Remember, we talked the other day, in order to find inverses, what do we have to do? We talked this yesterday, actually. We take the x and the y and we flip, right? Okay, so recall, to find inverse functions, you interchange is the word I used here, but you're going to take x and y and switch them, and then we're going to solve for y. Now, this may require us going between exponential form and log form. So we'll go back to our 3-word phrase for that one. There you go. You know it. I don't even have to tell you. I love it. Okay, let's look at example A. F of x equals 10 to the x plus 1. First of all, what do you guys know about f of x?
Y.
That is a fancy way for saying y. So this is really y equals 10x to the plus 1, if you will. Now, how do we find the inverse? What are we going to do? I'm going to switch x and y. So instead of y equals, I'm going to say x equals. Instead of 10 to the x plus 1, it's going to be 10 to the y plus 1. So what we did right there on that step is we switch x and y. So if you need a note to yourself, what did I do? How did this happen? There you go. Now, our job is to solve for y. Y is where? Y is in the exponent? Can we solve for y while it's in the exponent? We can't. How do we get it out of exponent form? Left, right, middle. Now, if you need to, I would suggest we flip this before we do our left, right, middle. Not everyone's going to need to, but it's definitely helpful. In terms of, in order to do left, right, middle, your base and exponent have to be on the left. So 10 to the y plus 1 equals x. Now, left, right, middle. What's the left? 10. So we're going to say that is what? Log base 10 of x, so of the right, equals the middle of y plus 1. And what did we do to get to this step? Left, right, middle. Okay? Now, easy step to finish. How do I get y by itself?
Subtract 1 over.
If it's y plus 1, good. We're going to subtract 1. If we subtract 1 on one side, we subtract 1 on the other side. Now, okay, in terms of writing this as an answer, I'm going to write over here. Y equals, what do we end up with? Log
10.
of x. Do I have to write that 10?
Now the base 10 already.
Okay, base 10 is the automatic base. You don't have to write base 10. Now, can you write base 10? Sure, you can write base 10 if you want. So log base 10 of x, and then what? Minus 1. Okay, you can write it in that form, or do you remember how we could take y and make it f inverse of x equals log of x minus 1? I don't remember how they put it on Savas, but the y or the f inverse of x would probably already be there. Okay, guys, can we do this? If you want to get technical, am I teaching anything new? We already know how to find inverses in terms of switching x and y. We already know how to do left, right, middle and solve those. So we're just putting stuff together we already know. Okay, guys, let's look at B. Now, what do we already know? G of x is a fancy way for saying y. So this is really y equals log base 7 of x plus 5. How are we going to find the inverse? Not yet. In order to find the inverse, switch your x and y, right? Take your x, make it y, take your y, make it x. So instead of y equals, x equals log base 7 instead of x plus 5, y plus 5. Okay, so that was me switching x and y. Okay, after you switch x and y, your job is to solve for y. What's the problem with solving for y? Y is in the log, yes? How are we going to get it out of the log? I'm ready to talk about those 3 words now.
Left, right, middle.
Left, right, middle. Okay. Now, if you want, go ahead and first of all make it log base 7 of y plus 5 equals x. Again, not saying you have to, but that puts my log on the left, which is what I need to do left, right, middle. So the left is what? 7. The right is x. 7. The left raised to the right equals the middle of y plus 5. Okay, that's your left, right, middle. How do I get y by itself?
Subtract 5.
If it's y plus 5, we're going to subtract 5. Now, would I go and write this out? Y equals what?
7x minus 5.
Okay, 7 to the x minus 5. Or if you put it in inverse notation, f inverse of x equals 7 to the x minus 5. Okay? I guess I didn't put a comment here that it was left, right, middle, but okay. Just trying to give you guys some steps. Okay, you've seen one of each type. We had an exponent that had to become a log. We had a log that had to become an exponent. 2 more? Okay. What do you guys know on C? Okay, it's the same as the first one. F of x is the same as saying y. So my starter equation is y equals 3 to the x plus 2. You don't have to write that part if you don't want to. In order to find the inverse, switch x and y. So instead of y equals, x equals, instead of 3 to the x plus 2, 3 to the y plus 2.
You didn't change colors.
You're right, I didn't. I was just, dang it. Man, I was trying to be so good. I want... Okay, I'm going to be kind of annoying here and go back and rewrite it in my other color. Okay, so x equals 3 to the y plus 2. I was trying to, okay. When I switch x and y, I'm switching colors. Okay, like that's the step I'm doing there. Now, with that in mind, we need to solve for y. Can I solve for y right now?
No.
No, because y is in my exponent. So, what do we need to do? Okay, I'm going to flip it so I'm set up to do left, right, middle. So 3 to the y plus 2 equals x. And again, this was my switch x and y step, right? And now we're going to do our left, right, middle step. So this is going to be what? Good. Log base 3 of x equals y plus 2. And at least the solving's easy, isn't it? If you can remember how to do left, right, middle, the solving's easy. How do we get y by itself?
Subtract 2.
Subtract 2. So I'm going to have y equals log base 3 of x minus 2. Or if you prefer, you could say f inverse of x equals log base 3 of x minus 2. Okay. One more? And you guys will have some work time? Okay. What do we know?
Y. Yep.
G of x is a fancy way for saying y. So y equals log base 7 of x minus 2. In order to find the inverse, we switch our x and y. So y becomes x, and x becomes y. That was switching x and y. Okay. With this in mind, what do we normally do next?
Reverse it.
Okay, reverse it, which we can go ahead and reverse it. Log base 7 of y minus 2 equals x. And we normally reverse it because we need to do a
Left, right, middle.
left, right, middle. Now, we have a slight catch. You can only do left, right, middle if you have log equals. Do I have log equals here?
No.
No, I have log
Why?
minus 2 equals. So, how do I move the minus 2?
Adding.
We're going to add the 2 to the other side, and the idea is I'm trying to get log by itself. In order to do left, right, middle, your log or your exponent has to be by itself. So now I'm going to have log base 7 of y equals x plus 2. Now, can I do a rewrite? Now I have the log by itself. So let's do our left, right, middle. What's the left? 7 raised to the right. What's the right? X plus 2 equals, what's the middle?
Why?
Y. Huh. So there was our left, right, middle step. And what do we do to finish it off? We can flip it to rewrite it, but y is already by itself, isn't it? So we ended up with y equals 7 to the x plus 2. Or if you prefer, f inverse of x equals 7 to the x plus 2. Okay? Okay, guys. You have some work time. Okay? Because of afternoon classes, I did officially bump and put the due date on Tuesday. But here's the other thing. Check out Skyward. How are your zeros doing? Are they magically disappearing because you're doing your makeup work? Okay? You've got 1 week. Everything needs turned in by the end of the school day next Friday. Okay? So, make sure you are making progress on getting stuff made up.